Assalamualaikum warahmatullahi wabarakatuh and good morning everyone. My name is Abdul Muiz bin Abdul Hamid from Mathematics 2 PPI SMP 2025-30. Today, I will be presenting on MTES 1142 Computational Thinking in Mathematics, focusing on solving non-routine problems using the sorting network heuristics. Before we start, I want you to think about this. In real life, do problems always come with a formula? The answer is, most of the time, the answer is no. That is why we need computational thinking, because it helps us to solve problems in structured and logical way, even when there is no clear method. Now, we go to the definition of non-routine problems. A non-routine problem in mathematical is a problem that doesn't have any direct formula or standard procedure, requiring higher order thinking, reasoning, and multiple strategies to solve, as stated by Lehman in 2025. What is the meaning of no direct formula? No direct formula means we cannot just memorize the step. We actually need to understand and think carefully. Now, we go to the characteristic of non-routine problems. The characteristics are no obvious method or formula, require higher order thinking, may have multiple solutions or approaches, needs exploration and decision making. Now, let's compare between non-routine problems and routine problems. First, we go to the routine problems. Routine problems, direct formula, one clear step, memorizations, and predictable, while non-routine problems, no direct methods, multiple strategies, thinking and reasoning, open-ended. So, basically, routine problems are like plug and solve, but non-routine problems are like we think first and then decide strategies, then we solve it. This is why non-routine problems are important in developing real understanding. Let's look at the selected non-routine problems. The first thing is the problems. A teacher wants to arrange 30 students into group for an activities. There is 3 rules, which is each group must have an equal number of students. Second rules, each group must have at least 3 students. And the last rules is the number of group must be more than 2. So the question is, how many possible group arrangements can be formed? At first glance, this looks simple, but actually it is tricky because we must satisfy all the conditions at the same time. Not all division of 30 are valid. So this is where computational thinking helps us organize our thinking. Now we move to the heuristic solutions using computational thinking. The first step is decompositions. Decomposition means breaking a complex problem into smaller, manageable parts. Instead of solving everything at once, we break it down into a few small parts, which is total students equal to 30, equal grouping required, minimum 3 per group more than 2. This step is important because it helps us reduce confusions. We clearly see what condition we must follow. And the next step is pattern recognition. Pattern recognition identifies similarities and structures in problem according to Ogekbo in 2022. We identify patterns by finding factors of 30. The factors of 30 is 1, 2, 3, 5, 6, 10, 15, and 30. Why factors? Why we use factors to solve these problems? We use factors because equal groupings means divisions, and division is related to factors. So instead of we guessing, we use mathematical structure. And then we move to the next step, which is abstraction. Abstraction means focusing only on important information and ignoring unnecessary details. It simplifies problem by removing unnecessary details according to Duckworth 2024. So for this problem, we need to ignore students' identity and we just need to focus only on numbers and grouping. This is important because too much information can make us confused. So abstraction helps us to focus on what really matters for this problem. And next is algorithmic thinking. Algorithmic thinking involves creating step-by-step procedure to solve problems according to Tang et al. in 2020. The first step is list factors. Second step, apply conditions. And the last step is filter valid answers. This step makes our solution more systematic, clear, and easy to follow. Now, we apply logical reasoning and evaluations. Logical reasoning checks whether each solution satisfies all the conditions, while evaluations ensure only valid answers are accepted. Okay, so we check each case first. One group equal to 30 students and the validity is not valid. Two groups will have 15 students and the validity is not valid. Three groups, 10 students and it valid. 5 groups, 6 students valid. 6 groups, 5 students valid. 10 groups, 3 students valid. 15 groups, 2 students not valid. 30 groups, 1 student not valid. So based on this table, there are 4 valid agreements, which is 3 groups of 10, 5 group of 6, 6 group of 5, 10 groups of 3. This step is very important because we are not just calculating, but we are justifying why an answer is valid or not. Next, we move to the relationship and insight. Computational thinking plays an important role in enhancing non-routine problem solving. It helps us individuals to structure their thinking, make better decisions, approach problems systematically. Through computational thinking, complex problems can be organized into logical steps, making it easier to analyze and solve effectively. This shows that computational thinking supports mathematical problem solving by structuring reasoning process according to Lehman in 2025. Now, insight and knowledge creation. This does highlight that mathematics is not only about performing calculations, but also about reasoning and understanding different approaches. It shows that one problem can have multiple valid solutions. Different strategies can lead to different answers. Moreover, computational thinking develops logical thinking, systematic thinking, creative problem solving. These are important in real-world situations according to Carter in 2025. Now we move to the next slide, which is reflections. Reflection on heuristic effectiveness. First, we go to the effectiveness. The use of heuristic combined with computational thinking provides a clear and systematic approach. It enhances understanding and encourages critical thinking. It guides learners step by step and improves structured thinking. The next is limitation. However, it can be time-consuming. It also requires strong conceptual understanding. Without proper understanding, learners may struggle to fully utilize computational thinking. So, this means computational thinking is powerful, but only if students really understand the concept. So, if we don't understand the concept, it was a bit hard for students to apply this computational thinking concept in their real life. So, our last slide is conclusions. In conclusions, computational thinking provides a structured way to solve non-routine problems by breaking them into manageable steps. It enhances logical reasoning, improves decision making, and allows multiple possible solutions. Ultimately, mathematics is not just about getting answers, but about developing thinking skills for real-world solving. I think that's all from me. Thank you.